Okay, up next, we have how MPC enables more expressive and programmable transacting by Nitya Subramanian at Capsule.
Hi everyone. I'm Nitya. I'll be talking about what Chloe just mentioned, so ways that MPC can enable more expressive types of transactions and some of the ways that we think about that at Capsule, which is the project that I'm building. So first, just a bit about me. I started my career in the fintech space, actually, and then worked on the Celo blockchain for several years, among other things, building a wallet, and started working on Capsule because kind of saw the possibility to think a lot more about the layer beneath the wallet interface as we describe it today. And that's a lot of what we're working on, and I'll share more about kind of how that plays into the topics today. So wanted to start with kind of bringing us up, like all the way up to the user interaction level. We've been talking about a lot of very deeply technical concepts today, but kind of thinking about blockchains at the most foundational level. Ultimately, blockchains are a new type of infrastructure with a paradigm where a user owns and controls data. The internet's, of course, not new, and we need to think a little bit about how blockchains fit into the internet. And so Slack is actually one example of this. I think really any Web 2 app that we use falls into this paradigm. But in Slack, I can click a button to make a post. I can maybe have that post happen a bit later, maybe when I'm asleep. I could maybe write a bot that posts on my behalf. And I can do all of this without necessarily specifying exactly what computation is getting executed. So, of course, in crypto, we would call all of these trust assumptions. And I think in the in this space, we've done a really good job of eliminating trust assumptions or minimizing trust assumptions when possible. But on the flip side, we've left ourselves with an interaction paradigm that's basically at the metal. So irreversible state, fully specified interaction. And unfortunately, we've lost a lot of these nice features that we take for granted when interacting with the internet more broadly. So as a result of this, there's now the pretty difficult task ahead where we have to decide what trust assumptions to reintroduce, when, how to expose them to users, et cetera, if we hope to have any of these nice features that have made kind of the internet as accessible as it is today. So if we kind of take this a step further and look at what the actual steps are to perform a transaction. So let's take a game, for example. We start with some interaction in an application, followed by some desire for action. Many would call this an intent right now. Then a transaction is proposed. It's maybe viewed or inspected within a wallet. Namely, it is viewed and inspected in a wallet, which is a separate product from where this intent originated. And then it's, of course, executed and settled. And won't go into any detail of anything below that, because, of course, there's a lot of exciting stuff going on at that level. So would be remiss to talk about any of this without mentioning account abstraction. Account abstraction builds on this because we are able to basically separate the initiation of transactions from the actual verification and signing of them. And so this is through features like session keys that are really helpful. However, in this paradigm, we do still need to go through the steps of proposing some transaction, visually inspecting them, and verifying them. Which is, of course, a challenge for many. And so kind of in summary, we're still in this paradigm where we don't have any trust assumptions or like well understood sets of trust assumptions, and are in a place where this manual inspection of transactions is like the only way that we can actually put anything on chain. And this is not a bad thing necessarily. Of course, in any system where you need a signature to access funds, any trust assumptions that you add introduce some attack vector where all of your assets could be stolen, your account could be compromised without any possibility of reversal. And so this is, of course, like there's a good reason this exists, but it's important to note that right now we're at a state where we are effectively rebuilding from the ground up and have not necessarily defined or have any well understood sets of trust assumptions that enable all of the features that we might want. And so the way that transactions fit into all of this is, of course, in the Web 2 world, we have these nice UX interactions where we push buttons, things happen. Sometimes things happen without us needing to push buttons. But in the crypto world, we have these really complicated interaction schemes where we need to be aware of specifically what L2 or what chain a specific asset's on. We might have assets on many different chains, but it might be the same asset, and we don't necessarily understand that, or we need to be very, very well aware of that. And even if the details of that are less important in our specific use case. And then additionally, we need to be physically inspecting transactions and kind of hoping for the best in terms of what that leads to. And this still has not necessarily created a world where everything that we intend to happen happens. Like there's still lots of accidents and lots of mistakes. So where MPC is interesting here is basically a couple of things. So everyone knows about MPC in the context of key management, key recovery, namely that we get some nice UX properties of not needing to have users write down seed phrases, as well as the ability to do key recovery. Additionally, we get some benefits of MPC that people don't talk about as much in the context of key management. So specifically, we get some privacy on signatures, on which keys provide signatures. And additionally, we get a separation of the signing of a transaction or the proposal of a transaction from ownership of the full key, which therefore would afford unilateral access. And so what's nice here is that we actually get a separation of concerns between proposing a transaction and then execution of some state or execution of some change over an account state. And then another nice benefit building on that is that you can actually allow many different applications to propose transactions, but then gatekeep or block execution at some point that is trusted. So of course, like any system where you have multiple applications that are all able to transact specifically on an account is not safe because it gives you least common denominator security. And so a notion of adding permissions onto this actually expands the space so that we can keep notions of security along the way. So there's actually a really nice Web 2 paradigm around operating on shared state, and that's SSO. Where in the example on the left, we see that SSO gives us the ability to manage different state and give applications the ability to even modify certain state within a Google account. In a blockchain context, what this actually can look like, and this is how we think about it, is you can have limitations at the transaction level, where you can give applications restricted ability to propose certain types of transactions and not others. And so this cleanly kind of creates a mechanism for specifying the type of state changes that different applications can make. So introducing a trust assumption, but in so doing, allowing the ability to do more automated types of transactions. And so I'll go a little bit more into how we think about this with Capsule. So we basically have a permissions layer, as mentioned earlier, where you can grant permissions up front. And then this adds an upfront step of giving permissions to an app. But it gives us the nice ability to remove these explicit proposal and signing steps. And so you end up with a transacting paradigm that can happen more in context without necessarily requiring multiple applications to perform a single action. I don't think we'll be able to like view the demo necessarily. Oh, we will. Okay, cool. Oh, great. Okay, perfect. Amazing. So this is basically how we think about it with Capsule. You can do something like create a wallet with an email, and then use an SSO-style verification that then creates a wallet that you can use to then perform signing in the background. This is like an on-ramp feature that someone could use to top up. And then what you see actually is the ability to transact without any separate standalone product. And then when you go to use other products in crypto, this same wallet could be accessible through a permission scheme, which we'll see later. So the same wallet now will have specific permissions that are granted to a wallet. And so provided those permissions are satisfied, transacting can happen in the background. In cases where they're not satisfied, we'd see one-off pop-ups that a user could either decline in this case or accept in another case. And so this is really a proposal of a certain kind of set of assumptions that we can add that then give us a lot of these properties around being able to do transactions autonomously from applications without standalone products required. Yeah, so if any of this was interesting, would love to chat more. Here's my contact info, and thanks a lot.
Do we have any questions for Nitya?
Yeah, thanks so much for the talk. One thing I'm wondering is, like in Web 2, a lot of the times when they ask for permissioning, they ask for pretty much access to all resources, right? And there's kind of this assumption that, well, if it's an app that I trust and they ask for admin privileges, I'm just going to grant it. How do you see that potential kind of social engineering attack in the Web3 space?
Yeah, I think what's interesting is that there in Web 2, as you mentioned, there is this like default trust assumption because we have the nice reversibility characteristic. I think for anything like this to work in the Web 3 context, it would need to be a default untrusted assumption. So until an application or a new party earns the privilege to be trusted with some certain action, the default should be to not trust. But given that assumption, we can then, I think, get to very similar levels of interaction.
Makes sense, thanks.
Amazing, thank you very much.